Hi everyone, and welcome to Get Good at Maths. This series we are going through last year's GCSE maths papers, and we got to question 10 on the first paper. So we will go through question 11 to question 15 in this episode.
Number 11. Cormac has some sweets in a bag. The sweets are lime flavoured or strawberry flavoured or orange flavoured. In the bag, the number of lime to the number of strawberry to the number of orange flavoured sweets are in the ratio of 9 to 4 to x. Cormac is going to take at random a sweet from the bag. The probability that he takes a lime flavoured sweet is 3/7. Work out the value of x. I would start by saying how many parts are actually in the bag. So 9 plus 4 plus x equals 13 plus x parts. And the probability of picking a lime flavoured sweet is going to be 9 out of this. So it will be 9 over 13 plus x. It says the probability of picking a lime flavoured sweet is 3/7. So that means 9 over 13 plus x must equal 3/7. And then we're just going to solve it for x. So let's times both sides by 7, and you'll get 63 on the top and 13 plus x on the bottom, and that must equal 3 because you've cancelled out the 7 and the 7 like this. Be warned, when you times by 7, make sure you times the top by 7, not the bottom, otherwise you've just divided by 7. And then we times both sides by 13 plus x. And they will disappear like this, and you'll get 63 equals 3, open the bracket, 13 plus x. And then I would multiply them out, so you'll get 39 plus 3x equals 63, and then deduct 39 from both sides. 24 equals 3x, and we divide both sides by 3, x equals 8. Number 12. Express 0.117 as a fraction. You must show all of your workings. If you're unaware, the two dots above the 1 and the 7, that means they recur and they go on and on forever. So the 1 and the 7 just go on and on and on. And there's a method to it, and we say let x equal 0.117, and that goes on forever. And we're going to try to multiply by powers of 10 in a way that eliminates the 1s and the 7s. And I'm going to see where it stops, and it starts repeating. So there's 3 of them. So I'm going to say that means 1000x equals 117.171717, and it goes on forever. And 10x will give you 1.171717, and they go on forever. And when you deduct them away from each other, you'll get 990x equals, and then these all cancel each other out when you take them away from each other. And you'll get 7 take away 1 for 6, and then you'll have your 111 in front. And then we divide both sides by 990, and you'll get x equals 116 divided by 990. It doesn't ask for it in the most simplified form, so we can actually just get away with writing it like this. A right-angled triangle is formed by the diameters of 3 semicircular regions A, B, and C, as shown in the diagram. And it says, show that the area of the region A, which is this one, equals the region of B plus the region of C. And I gave this a good think, and what I would do is I would say you've got the basic triangle of 3, 4, 5. That's a right angled triangle. And I'm actually going to double it and have the new one where it goes 6, 8, and 10. And you'll see why in just a minute. So let's assign A as the length 10, and B can be the length 8, and C can be the length of 6. And what I would do is I would half them. So that means instead of using 8, the diameter will the radius will be 4, and the radius will be 5, and the radius will be 3. And then it's just a matter of finding the regions of A, B, and C, and then seeing if they add together. So area for C will be, another formula for area of a circle is pi r squared. That's the area, and then you've just got to make sure you divide the whole thing by 2 for the area of a semicircle. So it's going to be 3 squared times pi, and then divide the whole thing by 2. 3 squared is 9, 9 pi over 2, and we can put that as 4.5 pi if you want to. The area for B is going to be, now the radius is 4, so it's going to be 4 squared times pi. Make sure you divide it by 2 at the end. 4 squared is 16 pi over 2, and then that will give you 8 pi. And then the area for A will give you, and it will be 5 squared times pi divided by 2, which gives you 25 pi over 2. I don't know why it changed colour, but it did. And that would give you 12.5 pi. And I would say to the examiner, so, oh, dear, 8 pi plus 4.5 pi, and that does equal 12.5 pi, doesn't it? And so I can just say proven. Number 14. Here is a speed time graph. Work out an estimate of the gradient of the graph at t equals 2. What we do is we go up from 2 on the t-axis, and we're going to work out the gradient at that point. So you take your ruler and you place it where it goes through the point, like this. And you take a line, this is called your tangent, and we're going to measure a triangle from the tangent. It's just making sure it goes perfectly on, like this. So where it goes through, and pick nice points, I would go for this point here, and maybe this point here. And you go across, and you find a triangle like this. And the triangle tells you the steepness of it, which is also called the gradient. The steepness of the triangle is, we say, the difference in your y-axis divided by the difference in your x-axis. So the y-axis travels through at 4.8 here, and it starts on 0.8. So the difference is 4. So your triangle is 4 tall, so it's going to be 4 divided by, and then it starts on 0 and travels to 4, so it's going to be 4. 4 divided by 4 gives you a gradient of 1. What does the area under the graph represent? This is the area under the graph, all of this section. And when it's time and speed, it tells you the distance. So the distance travelled. Number 15. A, B, and C are 3 points such that AB equals 3A plus 4B and AC equals 15A plus 20B. Prove that A, B, and C lie on a straight line. To be on a straight line, 2 things have to happen. They've got to go through a common point. So they've got to travel through the same point. And you can see they start on A, both of them. So that's one of them. And then the second thing that they have to have is they have to share a gradient, have the same gradient. Right, so we've got the common point and we just need to show that they're the same gradient. So 3A plus 4B and 15A plus 20B. If you factorize out a 5, so take a 5 out of 15 and a 5 out of 20. If you take a 5 out of 15A, you'll be left with 3A. And if you divide 20B by 5, you'll be left with 4B. So can you see they share the same gradient? It just means this is 5 times longer, A to C. And I would sum this up and say, I don't know, AC is 5 times longer than AB with the same gradient. In brackets, 3a plus b, that's the gradient. Oh, 4b. 3a plus 4b. And they both go through point A. Therefore, they are on a straight line. Right, part B. D, E, and F are 3 points on a straight line such that DE equals 3e plus 6f and EF equals minus 10.5e minus 21f. Find the ratio of D to F, which is starting on D and finishing on F, and D to E, starting on D and finishing on E. So D to E is really nice because it's literally what it says, 3E plus 6F. D to F, that's a tricky one. So D to F means you've got to travel from D to E and then E to F. So D to F equals 3E plus 6F. That's the first part. And then you're going to have to add minus 10.5E minus 21F. 3 take away 10.5e will give you minus 7.5e. 6f plus negative 21f will give you minus 15f. So it's in the ratio of this to the ratio of that. 3e plus 6f. So this is your df, and then this is your de. Because it's a length, it doesn't actually matter that it's negative. So if we could put 7.5e plus 15f, it actually doesn't matter because it's the same length. And then it's a little bit easier to deal with. Factorizing is the way to go. So let's factorize the right-hand side first. And they've got a common factor of 3. So let's take a 3 out. And then you'll get e plus 2f, like that. And this has got a common factor of 7.5. So if you take out 7.5, you'll get an e left over, and then 15f is just double, so it would be 2f. And having the same length, sorry, the same gradient is the way to go. And then this determines the 3 and the 7.5 just determines the length. So the ratio is 7.5 on the left-hand side and 3 on the right. 7.5 to 3.
Well, there we are. It had me scratching my head slightly at the Pythagoras question, but it wasn't too bad. Once you think about it, it's not too bad. So yes, join me tomorrow, and we will go through the next 5 or 6 questions. We will go up to question 20, and then we'll make an individual video by itself for that tricky segment sector question. Okay, cheerio.